Hey, how's it going everyone? This is Mike with GrowersHouse and I got another Ventana Plant Science video for you. So today we're gonna talk about batching, feed rates, and dosing through fertigation systems, through hand, whichever method your facility is designed for. We're gonna try to touch base on all of the kind of different ways that you can apply VPS to your plants. So the first and most obvious way is you can do a gram per gallon and then just make your own actual standalone batch. Generally, that's not what we recommend. When we have you melt these fertilizers down, we would really rather you use them as a stock liquid, because using them as a stock liquid is going to bake in that pH requirement, and it's gonna make sure that everything is fully melted down into a stock solution before it hits your tank. So there is less of a chance for negative interactions while the nutrients are melting in that tank if you use our stock solutions. So we went over making these stock solutions in the last video. Now we're gonna talk about how we use these stock solutions. Now, again, you can do this dosing by hand according to the VPS feed charts that are out there. They have like an indoor optimized feed chart, they have outdoor feed charts, 2-stage, 3-stage. So whichever nutrient feed chart you're using from VPS, just know that those rates are for whatever grow style that they're specifically mentioning for those feed rates. Today, we're just gonna use a basic indoor rate to test certain compatibilities and to talk about kind of like the best systems or the best options available to most growers as far as modern dosing solutions. So the first thing that we'll talk about is hand batching. Really easy. The feed charts generally have a milliliter per gallon on there for each product. You make the stock solutions according to the manufacturer's recommendations. You have these stock solutions and you measure them out by milliliter per gallon. Pretty easy. For like week 1 of flower, you're gonna have 27, 17, 11, or 12, something like that as far as your bloom, calcium nitrate, and magnesium sulfate. And of course, those rates can vary through different phases of your growth cycle. So hand batching, very simple. You get as many mils as you need based on how many gallons that you're batching. So if you need 300 gallons to go to all of your plants, then you multiply that 27 mils per gallon by 300, and that's gonna be the amount of milliliters of the stock solutions you'll need for that 300 gallon batch. Same thing with the calcium nitrate and the magnesium sulfate. Instead of weighing them by gram, you're just measuring them by milliliter as a stock solution, which in our opinion, safer, less interaction, more consistent. So hand batching, very easy. You're just gonna measure out how much you need. Now, when it comes to automatic dosing is where the options just explode. You have Dosatrons, you have H.E. Anderson pumpers, you have systems that control H.E. Anderson pumpers, you have peristaltic pumps. There's a wide variety of options for growers to dose certain chemicals or nutrients into their irrigation water. First thing that we're gonna talk about is Dosatrons. So with the stock rates that VPS prescribes and the delivery rates that they generally recommend as far as mils per gallon, most Dosatrons within the 0.2 and up range are gonna be fine for use with the VPS program. For Dosatrons, generally VPS recommends that growers have about at least four dosing units, as well as at least 2 mixing chambers. So generally on a Dosatron line with your 4 Dosatron units, you're gonna have your water starting system, your Hick start, and then the first stage is actually gonna be silica. So VPS recommends that you run that silica first, like most silica products. But the key with the VPS silicon is since it's at such a low rate, 0.5 ml per gallon, the pHing aspect is almost negligible. So that's kind of nice. And when you're using it through a Dosatron, generally, unless you have a very accurate doser that can do 0.5 ml per gallon, generally you're making a diluted stock solution of that silicon anyway. So that first stage is gonna be silicon. The next stage after that, we're gonna recommend the bloom tank. So you're gonna go from your silicon to your pH balanced bloom tank, set at the rate that you wanna deliver at that phase of growth. And then the next thing on that Dosatron line is gonna be a mixing chamber. You wanna make sure to have that mixing chamber after the bloom phase so that the water, the silicon, and that bloom concentrate gets fully mixed and homogenized in that water going down your Dosatron line. A lot of the times, if you don't have that mixing chamber, the water doesn't get fully mixed in with that bloom concentrate at volume, and you can have negative interactions on your injection kind of outbound rail. This happens on either Dosatrons, or large systems like H.E. Anderson's, large systems like Argus, Previs, Netaflex 3Gs. The pH considerations on your injection rail is very important, and as well as the amount of water being mixed with your concentrate before it gets to the next step. So now that we have a mixing chamber and we have sufficient water volume and sufficient mixing of that concentrate into that water volume, the next dosatron, the next stage, the third dosatron is going to be our calcium nitrate. Calcium nitrate, very simple, very soluble. It's a single nutrient. As long as it is added to a well-mixed nutrient solution going down the line, no negative interactions. Same thing with the magnesium sulfate. Now you have our 2 dosatrons, a mixing chamber, 2 dosatrons, and then finally you're gonna have one last mixing chamber to ensure that you're getting enough water volume and enough mixing to make sure that that nutrient solution is fully homogeneous, and then it's gonna get sent out to your plants through filters, through solenoids, however your particular irrigation drip design is set up. So we've covered dosatrons. It's a pretty standard way to dose nutrients into fertigation situations. However, a lot of the times you don't really want to be adjusting the rates on the dosatrons constantly. So if you do want to have a 2 to 3 phase type of fertigation program, one thing that we recommend is having a dosatron line for each phase. So instead of changing the rates on the dosatrons themselves, which is kind of more prone to error and the adjustments are not that perfect, what I recommend is you set adjustments for your 3 different phases on 3 different dosatron lines, and you use something like electronic water solenoids to control where the water goes in and then where it goes out as far as where it's being delivered to, what room or section. So that's a basic dosatron layout. If you have any more questions or if you want kind of a more customized or a fully explained layout, feel free to reach out to GrowersHouse for any of the technical crop advisors. We're always happy to make a dosatron system setup for you. The next step up as far as technology-wise is going to be your pneumatic pumpers with control systems, things like the series system, anything that basically utilizes like an H.E. Anderson pump, pumper system, pumper doser. So that is going to be a little bit more flexible in the fact that you can dial in how many mils you need, and then the electronic system can actually link up with the solenoid or the actual dosers and vary that rate. So you can have your 2 or 3 phase cycle without having to manually adjust anything on your dosing units. That's really cool. Netaflex 3G, the Previs systems, the Argus systems, all of those are basically batching systems. What they do is they have stock injection, and they'll inject that usually into a single batch tank where it gets mixed and then either sent to a larger day batch tank or sent directly to the plants. One huge consideration when it comes to those types of systems like a Netaflex or an Argus or something like that that has a central batching system and injection rails that all meet up or are in line is pH in your stocks. With the Ventana Plant Science program, since you are pHing your bloom, you understand the pHing requirements of your main nutrient, and then you don't really need to pH the calcium nitrate and the magnesium sulfate because they generally melt out at the ranges that we would want, about 5 to about 6.2. So if those are melted out and we have our stock tanks all within that 1 to 2 range of pH, then we really shouldn't expect any negative interactions along our injection rail where all of the different nutrients are going in, or in the main batching tank itself where all of the injection points meet up. A lot of the times, if you have a stock tank that's at like 4, 3.5, 4.5, really low, something that you'd expect with a lot of other kind of hydroponic-based fertilizers we see, you're going to ideally want all of the other stocks to be about that same range, or you can pH those stocks to be a little bit higher to meet those ranges. Because what can happen a lot of the time is if all of your stocks are very low pH and you try to adjust those low pH stocks with a pH up product, it's going to be too big of a swing between the fertilizer's pH and what you're adding to increase the pH that you may end up crashing out and getting precipitates. So a big consideration when using an automatic dosing system or an automatic batching dosing program like Argus or Netaflex is to make sure that you get your stock tanks as close to each other on pH as possible so that you don't need to have a drastic pHing injection later on during the batching. So in any fertilizer program, the mixing order is extremely important. There's a lot of considerations as far as like your ion type, like your phosphates, your sulfates, etc., and your pH, what the pH of each step is going to be. So for the VPS program, generally what they're going to recommend is their silica first, their bloom product next that has been pH balanced, the calcium nitrate, and then the magnesium sulfate. That mixing order is going to carry on through either hand mixing, Dosatron setups, or the timing on the injection of a larger dosing system like a Netaflex 3G. If you don't have the ability to do that, it's not that big of a deal because those types of systems all batch into one tank. But generally you want that order to be from silica, bloom, calcium nitrate, and magnesium sulfate. So now that we have our stock tanks made and pH'd and we have exactly what type of a dosing, or at least a general idea of the dosing setup that we want to use or are going to use, one big thing we need to do is confirm that everything's working correctly. Confirm that the pH is coming out exactly where we want. Confirm that the ECs conform to the feed charts. So once you set your dosing system, especially on something like a Dosatron system, you really want to run all of those Dosatrons at maximum pressure for about 4 to 10 minutes, just to make sure that all of the pickup tubes on the dosing system is fully filled, you have no air bubbles, and you're getting accurate dosing every pulse. Because what can happen is a lot of the times in the beginning of an irrigation cycle, your dosing system kind of catches up to the water pushing through it, and it won't get to full consistency until about that 4-minute mark or later. So what we recommend is, if you can, when you first set up these dosing systems, let them run for a couple of minutes, just let them flush through, and then measure the EC and pH of your output at that point. At that point, after a few minutes of running the system, it should be consistent enough for you to get a better idea of where exactly you're gonna finally land as far as EC and pH of your final nutrient solution going to your plants. So making sure you check what's coming down out of your drippers, making sure you check what's running off of your plants is gonna be two very important tools as well, just for daily upkeep of making sure that your dosing and your fertigation program conforms to exactly what's going onto the plant, and that what's going onto the plant matches what you expect your delivery should be based on how your dosing system is set up. So now that we have the tools to check whether or not we're dosing correctly by using our runoff readings, using our dripper readings by just having 2 drippers on each bench or something, or each section, or getting a sample of your finalized solution to know this is what I put on the plants, this is my runoff. So now we know what we're putting down, and we know what's coming off of the plants, and what's coming off of the plants can kind of determine how we adjust our rates of what we put down later on. So that is a general rundown of what to expect as far as batching goes. There are a few key do's and don'ts that I want to go over with the Ventana Plant Science program especially. One thing that's unique about Ventana Plant Science's program is they don't really expect you to add an acid and then add a base later on. So what happens with a lot of growers is they're used to playing the back and forth game with acids and bases, where they add too much acid, then they balance it out with base, or they add too much base and they balance it out with more acid. We generally don't recommend you do something like that with the VPS program. You really want to keep your pH adjustment all kind of one direction. So ideally, your 3 salt stocks should blend out to bring you to the finalized solution of about 5.7 to about 6.2 of your final nutrient solution, which is absolutely fine to just deliver straight to the plants. Now, if you are a little bit out of those ranges, instead of doing an adjustment after the fact, what we recommend is you go back to the VPS Bloom stock tank and you increase that Bloom stock tank either slightly if you need to bring your pH up, or you decrease it if you need to bring your final solution pH down. What you don't want to do is create a solution that's off balance as far as pH and then try to kind of brute force the pH back up after the fact. Sometimes, depending on what type of product you're using, if it's not a good potassium hydroxide, you can build up precipitates. So now that we know a couple of the dosing systems that we can utilize, whether it's Dosatrons or something more advanced, one thing that I really want to touch on is compatibility. So in the ag world, something that's very common when you want to put down multiple different types of products is something called a jar test. You generally want to jar test all of your products before you use them through a fertigation system, just to ensure high compatibility. So in front of me, I got some graduated cups that have the VPS flour solution in there. This is pH to about 5.9, 6.0-ish, and it is about 2.2 on the EC. So this is more of a outdoor greenhouse formula. So what I'm gonna do now is I'm gonna go ahead and add a couple of products that I've seen have a little bit of incompatibility in the field from people using it. And I'll explain what each product is and why you really shouldn't have to use it with VPS. So the first product I want to add to this little batch right here, this little mini batch, I'm going to go ahead and bring it into this. And we'll just go ahead and do a couple of drops. Going to bring it up, usually. So as you can see, we're getting a little bit of cloudiness in our solution. So that was a potassium silicate product. Obviously, it's gonna be pretty basic. So when you're adding potassium silicate products or any of your pH adjusting products, if you're adding something to increase the pH, you really have to make sure that you dilute it down as much as possible. If not, you're gonna start to get a little bit of precipitates form. So with potassium silicates and potassium hydroxide, if you're adjusting your pH of your final solution up, you do not want it to be a drastic change. You want that to be incremental. And if you can't be incremental and you do need to make a drastic change in pH, you have to dilute that potassium silicate or potassium hydroxide with water so that you don't get these negative interactions. So the next test I want to do is for on hypochlorous acid inside of VPS. A lot of people like to inject hypochlorous acid to keep their drip systems clean while they're running them. So I'm just going to slowly add a few drops of this in. We're going to bring this up. We're going to give it a swish. You might even want to give it a stir, but as you can see right here, clear. We're getting no cloudiness, no precipitates forming. So as you can see, hypochlorous acid has no real negative interactions with the VPS program. So hypochlorous, if you want to inject it at a low rate and you have the dosing channel to do that, that's great. It'll just extend the maintenance intervals of your fertigation system. All right, so now I have one more very common pH adjusting product that I want to try to do a jar test on to see if there's any negative interactions. And this is going to be potassium carbonate. So I'm going to go ahead and bring a little bit of that potassium carbonate up, melted at the stock rate. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. It's a good little test. I'm going to bring that up. And as you can see, we're getting a little bit of precipitates coming out. You see a little bit of cloudiness forming. So anytime you see this cloudiness forming, it's too stark of a difference in pH swing, is generally what that means. When you have too big of a swing between what you're trying to change and what you're using to change your pH, you're gonna get this cloudiness. Now, sometimes that will dissipate. Other times, if the injection point is constantly creating precipitate, eventually it hits areas within your fertigation system where it can accumulate and build up. And that is gonna be a lot of the stuff that clogs your filters, your drippers, your emitters, gets stuck as sediment at the bottom of your batch tanks. It's these small amounts of precipitates that form when we have these wide pH swings that we really have to be on the lookout for. So when you're doing any sort of nutrient trial, or if you're trying to see what the compatibility of the other components of your nutrient program are with your actual raw salt nutrition, then doing a jar test is a very important and key tool to kind of figuring out compatibility, so you don't have to spend too much time, money, and energy trying to keep maintaining your fertigation system because it keeps having issues because you're building up precipitates either in the lines, in the drippers, or in your batching areas. So now we know how to make nutrient batches, whether it's by hand batching, by measuring milliliters, using Dosatrons, or any other sort of more sophisticated dosing equipment you have out there. Now that the dosing and the batching is done, and we have our jar test and compatibility test done to know that the products that we have in our fertigation program work well, the last step of the puzzle is to be consistent. You know, you really want to do those leachate readings. You really want to do those readings of what you're applying onto the plants. And you want to make sure you have a good system of maintaining your drip equipment, whether it's your filters, your main lines, your actual drip emitters, things like that. And all of that plays into having a good comprehensive fertigation program. And if you have any questions about dosing, batching, or dosing and fertigation systems in general, reach out to Cannabis or the TCAs at GrowersHouse. If you have any questions about Ventana Plant Science, please reach out to them at ventanaplant.science and they'll be able to answer any questions for you. Thanks for watching. I hope you learned something. And remember, keep growing.